speak, we have two scenarios. The first scenario is an intersection of two sets contains items that are in both of the two sets. General approach. To find the intersection of two sets without using the built-in methods, I first create an empty set, and then I can iterate over one set and check if each element exists in the other set. If it exists, I add it to the result. To do this, first I create a function. This function has two inputs, the set A and the set B. And then I initialize an empty list or set called intersections. And after I use a for each loop and traverse each element of set A. For each element, check if it is also present in set B. If the element is found in both set A and set B, I add it to the set I created earlier. And finishing, I return the created set. This function has a big O performance of On because I'm iterating over the set A, and the big O is On, where N is the size of the largest set, the set A or the set B. Test cases. To test this function again, the test case 1 could be set A contains the items 1, 2, and 3, and the set B 2, 3, and 4. And the expected result would be 2 and 3. And for a test case 2, the set A contains 1, 2, 3, the set B 4, 5, and 6, and the expected result would be empty because they not contains common elements. And for a test case 3, the set A could contain 2, 20, and 30, and the set B 30, 20, and 10, and the expected result would be 10, 20, and 30. And the second scenario is a union of two sets contains all items that are in either set. And for this scenario, to find the union of two sets, we can combine all the elements of both sets. We simply need to iterate over both sets and collect all the elements into a new set. Since sets automatically handle duplicates, there is no need to perform additional uniqueness checks. For this function, the inputs would be also two sets, the set A and the set B. And after that, I can initialize an empty set called union. And after that, using a for loop through each element of set A and add it to the union. And after that, create another for and loop through each element of set B and add it to the union. And finishing, I can return the union. The big O performance for this is that I can iterate over set A and set B once. Even though there are two loops, because they are not nested inside one another, the performance would be O2n, which simplifies down to On when the constant is dropped. And I have two test cases. The test case 1 is when the set A contains 1, 2, 3, and the set B 2, 3, and 4, and the expected result would be 1, 2, 3, and 4. And for a test case 2, then the set A would be 1, 2, 3, the set B would be 4, 5, and 6, and the expected result would be 1, 2, 3, 4, 5, and 6. And for a test case 3, I have the set A that contains 10, 20, and 30, and the set B contains 30, 40, and 50, and the expected result will be 10, 20, 30, 40, and 50.